During the chaos of World War II, where every ounce of material and every second of warmth could determine survival, ingenuity thrived in the unlikeliest of forms. Among the many forgotten field inventions of the war, few were as effective or as controversial as the soap and alcohol Firestarter. What began as a simple soldier's trick for lighting fires in cold, wet environments evolved into something far more powerful, earning it a post-war ban due to its unpredictable and destructive potential. It wasn't a weapon in the traditional sense, but in the right or wrong hands, this homemade compound burned hot enough to start engines, melt metal, or set enemy supplies ablaze. This isn't some romanticized myth, it's documented fieldcraft. The mixture, known in some Allied circles as field napalm, was a crude forerunner to later incendiary compounds. Soldiers discovered that by combining soap shavings with high-proof alcohol or even medical spirits, they could create a thick, sticky gel that clung to surfaces and burned long enough to ignite damp wood, fuel lines, or even heavy tarps. What made it infamous wasn't just its efficiency, it was how easy it was to make with standard field supplies. The discovery began as a desperate attempt to start fires in frozen terrain. The origins of this mixture trace back to the winter campaigns of 1942 to 43, particularly on the Eastern Front. Troops on both sides battled not just each other, but the elements. Temperatures regularly fell below -20 degrees Celsius, rendering traditional fire-starting methods useless. Matches snapped from the cold, lighter fuel froze solid, and even gasoline refused to ignite properly. In the field, warmth wasn't a luxury. It was the difference between frostbite and survival. It was during these moments of desperation that soldiers turned to field chemistry. Medical alcohol, ethanol or isopropyl, was common in aid kits. Soap was part of every ration issue, meant for hygiene but often traded or repurposed. When grated soap was mixed into alcohol, it created a semi-solid gel that behaved differently from either ingredient on its own. Once ignited, this gel didn't burn off instantly like liquid fuel. Instead, it clung to the burning surface and produced a steady, sustained flame, even under freezing wind. Reports from the German Wehrmacht and Soviet troops alike mention similar concoctions. The Germans referred to it as Seifenbrennstoff, or soap fuel, while Soviet units called it white fire. By the middle of the war, its use had spread across various fronts, often passed between units informally. It wasn't officially sanctioned, but it was quietly tolerated. Well, at least until soldiers began weaponizing it. The trouble began when troops realized that the soap alcohol gel could adhere to almost anything, uniforms, vehicles or walls, and continue burning. When mixed with additives like petrol, kerosene or paraffin, it became terrifyingly potent. Field notes recovered after the war describe small tins of the mixture being used to sabotage enemy trucks or equipment at night. Just a single handful thrown under a fuel drum or into an engine bay could cripple machinery. Allied forces experimented with similar recipes, and by 1944 military engineers had begun formalizing this field discovery into controlled tests. What they found was both remarkable and dangerous. The soap component acted as a stabilizer, transforming volatile fuel into a manageable gel that could be shaped, stored and transported with relative safety. In other words, soldiers had stumbled upon the chemistry of gelled fuels, decades before it became standard in modern warfare. But with its newfound potential came consequences. Commanders quickly realized that the compound's unpredictability posed as much risk to the user as to the target. The thick gel could flare unexpectedly, and fumes from impure alcohol mixtures sometimes caused poisoning or explosions. After the war, as nations codified international rules on chemical and incendiary weapons, field manuals quietly omitted references to the mixture. By 1949, its production and use in military contexts were officially prohibited. At its core, the banned World War II Firestarter worked on the principle of viscosity and surface adhesion. The soap, often made from animal fat and lye, contained long-chain fatty acids that bonded with alcohol molecules to form a primitive gel. This gel burned hotter and longer than liquid alcohol because it released fuel gradually rather than all at once. The soap also acted as a wick, drawing fresh alcohol to the surface as the top layer burned away. That slow, controlled release was what made it invaluable. A tablespoon of the gel could sustain a flame for several minutes, long enough to dry wood, heat a mess tin, or ignite frozen kindling. In practical terms, this meant that even when temperatures dropped so low that traditional fuels failed, this mixture could keep soldiers alive. Modern survivalists can adapt this principle safely using non-toxic materials. For instance, mixing a small amount of clean soap flakes with rubbing alcohol in a metal container can produce a slow-burning fuel for emergency use. Never store it in sealed plastic, and always ignite it outdoors or in a fireproof enclosure. The key is proportion. Roughly 1 part soap to 3 parts alcohol yields a workable gel that won't spill or evaporate quickly. After the war, fragments of this technique resurfaced in civilian life. In rural Europe and North America, people used similar mixtures to light wood stoves or start campfires in the cold. Soap-alcohol gels even appeared briefly as improvised heating fuels in emergency ration kits during the early Cold War era. However, once pressurized gas and solid fuel tablets became widely available, the method faded into obscurity. Today, few remember that this wartime invention paved the way for modern gel fuels used in camping stoves and chafing dishes. The only difference is control. Modern versions use purified alcohol and stabilizers, ensuring a consistent and safe burn. Yet the chemistry is nearly identical to what soldiers crafted in the trenches over 80 years ago. The banned World War II Firestarter stands as a perfect example of battlefield innovation. Resourceful, practical, and, well, a little dangerous. It reminds us that necessity drives invention, especially when human survival is at stake. Understanding how such simple materials could be transformed into reliable fire-making tools deepens our appreciation for wartime ingenuity and, honestly, offers valuable lessons for modern preparedness. For anyone interested in survival skills, it's a powerful reminder that effective solutions don't always come from technology. They come from understanding chemistry, environment, and resourcefulness. In an emergency, knowing how to create a stable, long-burning heat source from basic materials can be life-saving. And though we no longer use the wartime formula in its original volatile form, The knowledge behind it still applies to safe, modern fieldcraft. The story of the soap and alcohol Firestarter isn't about glorifying destruction. It's about understanding resilience. It shows how, even amid scarcity and chaos, soldiers turned common rations into tools of survival. And while the world may have banned its use as a weapon, the chemistry behind it remains one of the most fascinating examples of wartime ingenuity ever recorded. If you're drawn to uncovering these forgotten innovations, the tools, tricks and tactics that defined survival during humanity's darkest hours, then you're in the right place. Here at Echoes of Valor, we dig up the lost knowledge that once shaped the world. So if you haven't already, subscribe, share, and help keep this history alive. Because the lessons of the past aren't meant to be buried. They're meant to keep us ready.